Welcome back to day 2 of hyperbolas class. Today we're going to be looking at hyperbolas that are no longer centered at 0, 0. And we've seen this with our parabolas and our ellipses, so there won't be a lot different, but there are a few things that we do have to think about. Before we get into the moving of these, the shifting of the graph, I do want to remind you of a few key points about the hyperbolas in general. Remember that with hyperbolas, you do want to look at which variable comes first. So in this case, for example, if the x comes first, then we know that these branches are going to be opening left and right, just like the x-axis. Remember that the a value here is going to be sending us to our vertex points, and the b value is going to be sending us to what I refer to as the covertex, although technically the covertex points are not part of the graph themselves. So if we look back over here on our picture, this distance would be our a value to our vertex. This distance is our b value. The c value, just like before, is going to send us to the focus points. So on our picture, there would be my c value. And then remember that the relationship between the a squared, b squared, and c squared is a little different. This time we are adding a squared plus b squared to get c squared. Now, it's the asymptotes, though, that we are going to be talking about. We have to come up with the equations of these asymptotes, and because we've moved the center, it's not going to be exactly the same as the equations that we came up with when the center was at 0, 0. So before we write the equations of those, I wanted to do a very quick algebra review of point slope form and how we would write the equation of a line in point slope form. If I gave you 2 points on a graph and said write the equation of the line in this form, we would start by simply finding the slope. Now keep in mind, if you are graphing it, you could find the slope by counting on the graph. Otherwise, we'd find the slope by doing our change in y over change in x, which means I subtract the y's and subtract the x's, I'm going to get a slope here of -1 over 3. But in this particular example, I do not have a y-intercept. Remember that a y-intercept would have to have an x value of 0, and neither of these points has an x value of 0. So because there's no y-intercept, I'm not going to be using this equation to write my line since I don't know the b value. Instead, we're going to go back, we're going to go back and use what we call point slope form, which looks like this. In point slope form, we can plug in our slope, so we know that our slope is -1/3, and we can pick one of our ordered pairs to plug in for the x and the y, the x1 and the y1. So I'm going to be plugging in 4 for my y1, I'm going to plug in 2 for my x1, and my equation in point slope form is y minus 4 equals -1/3 x minus 2. Whenever we do not have a b value, a y-intercept, and we have a different point, we're going to have to use this point slope form to write our equation. So going back up here to our hyperbola, we want to write the equation of these asymptotes. Now, finding the slope we can do from looking at the graph. Remember that we said for this one, we went up b units, and we went right a units. So our slope here is b over a. And our slope for this other asymptote would just be -b over a. So we already know what the slope is, +b over a. But since this graph doesn't go through the origin, and instead it goes through this center point HK, we're actually going to have to use the point HK and plug both pieces of information into our point slope form. So when we go to write the equation, we're actually going to be plugging in h for our x1, so we'll plug in h. We're going to plug in k for y1, so we're going to plug in k, and we've calculated our slope. Our slope is ±b over a, so our equation is y minus k equals +b over a times x minus h. Now again, this is not an equation you need to memorize. I wanted you to see how we're deriving the equation so that you can write the equations yourself. When we look at a hyperbola that is has a vertical transverse axis, so we say it opens vertically, again, notice that the y comes first and that's how we know that this one is opening up and down. Everything else is going to stay the same, but I do need you to think about the asymptotes. Since the A is under the Y, we actually went up and down A units, which means that from our graph here, we went up A units and we went down A units. Then we went left and right B units. So that means that this was B, this was minus B, okay? But the key is think about your slope when you're writing your asymptote, because this time, since we went up A and right B, our slope now is A over B, not B over A. And the slope of this one is negative A over B. So when we go to write our asymptotes, our slope could be a positive or a negative A over B. We're still going through that center point, HK. So our equation for this asymptote would be y minus k equals positive and negative A over B times x minus h. Okay, so now looking at a couple of examples. First, what we want to do here is graph the equation. Then we're going to list the center point, the vertices, there will be 2 of them. The focal points, again, there will be 2 of them. And we want the equations for the asymptote. So we're going to have to do a little bit of work there to write those equations. Okay, first, notice that since the x comes first, we know that this hyperbola is going to be opening left or right. My A value is going to be 2. My B value is going to be 4. And my center point is at 2. And then remember, it has to be in terms of subtraction. So technically, my center point is at 2, negative 1. So we'll start with identifying our center, plotting our center, 2, negative 1. And then from our center, we can start moving up, down, left, and right. Okay, we're going to start with moving left and right 2 places. So we'll go 2 places right, 2 places left. And remember, these are our vertices. So our vertices are at 0, negative 1, and 4, negative 1. Okay, then we're going to be going up and down 4 places. I'll stay with blue. We're going to go up and down 4 places. So 1, 2, 3, 4, 1, 2, 3, 4. These are our co-vertices, which I'm not actually going to identify, but we're going to use these to be able to now draw this rectangle connecting the vertices and co-vertices. We're going to draw the diagonals of that rectangle. These diagonals are going to become our asymptotes. And then we're going to use these asymptotes to actually come back and draw the branches of our hyperbola. We want to make sure that they are approaching the asymptote, so that's going to tell us basically how wide to draw them. Now, for the focal points, we're going to need the c value. So remember that a squared plus b squared equals c squared. A squared is 4, b squared is 16, which means that c squared is 20, and c is the square root of 20. Simplified, that is 2 square root 5, and as a decimal, that's approximately 4.5. So when I plot my focal points, I'm going to switch colors for these. When I plot my focal points, I'm going to go to the right 1, 2, 3, 4.5 places, and to the left 1, 2, 3, 4.5 places. So here's my focal points. When I write the focal points, though, I do want to use the exact simplified value. Notice that both focal points are going to have the same y value as the center and as the vertices here. So my focal points both have a y value of negative 1. What I did when I was writing my focal points, though, is I started at my center point, which had an x value of 2, and then I added that 2 root 5. So I'm going to write 2 plus 2 root 5. Then, back at my center point of 2, then I subtracted 2 root 5. So 2 minus 2 root 5. And again, there's my focal points using exact values. As for the asymptotes, I'm going to first need to know the slope of my lines. If we think about the distances that we went, remember that we went up 4 units and we went right 2 units. So the slope is 4 over 2, or simply 2. And the slope of this one is negative 2. So I could say my slope is positive or negative 2. We also know that this graph went through the center point. And remember, our center point we had as 2, negative 1. So when I go to write my equation in point-slope form, and I'll write that point-slope form one more time, we're going to be plugging in a slope of positive and negative 2. For my x1, I'll plug in my x value of my center. For my y1, I'm going to plug in my y value. And remember, when we simplify this, we can write y plus 1 equals positive negative 2, x minus 2. And it is perfectly fine to leave it in slope-intercept form. If you want to rewrite it in point-slope form, if you want to rewrite it into slope-intercept form, you could quickly do that, but you would end up having kind of two equations because you would have to distribute that positive 2 and that negative 2 separately. So be very careful if you are going to be rewriting it. Make sure you do it twice. Okay. Well, we did all of this up above, so we'll skip over that. Okay, so now when we look at this one, there's a couple of things we need to look at here. Number one, it's obviously not in the form that we're familiar with. But number two, we also need to be able to recognize what type of conic section this is. So there's a couple of things I want you to look for. The fact that we have an x squared term and a y squared term, so the fact that we have both x squared and y squared tells us that this is not a parabola. Remember that parabolas only have one squared term in them. Now, the question is this an ellipse or is this a hyperbola? Okay, with an ellipse, remember that our equation is going to have an x squared plus y squared equals 1. And of course, we have denominators. But with a hyperbola, we have, well, we don't know what order they're in with a hyperbola, but we do know with a hyperbola that we subtract the fractions and it equals 1. The fact that one of these is negative and one of these is positive tells us that we have to be looking at a hyperbola because we are looking at different signs. So one of the things that I want you to be paying attention to is the recognizing what type of section it is. If you have both variables squared somewhere in your equation, then it's either an ellipse or a hyperbola. If the squared terms are the same sign, then it's an ellipse. If the squared terms are different signs, then it's a hyperbola. So now that we've identified that it's a hyperbola, now we need to get it into the right form. And just like we've done before, we're going to do a little bit of grouping and moving some things around. So we'll start by grouping together your x terms, negative 16x squared and negative 64x. Group together your y terms, so y squared minus 6y, and then bring any constants over to the other side, so we'll say equals 71. Okay, if your x squared and y squared terms do not have a coefficient of 1, then your next step is to do a little factoring. So right here, I'm going to need to factor out a negative 16, leaving me with a positive 4x in here, okay? And I don't need to do any of that factoring with my y since my y squared already has that coefficient of 1, so that one we can leave alone. The next part is completing the square. So with my x terms, I'm going to write a perfect square trinomial. Then with my y terms, I am going to again write a perfect square trinomial. And then remember, whatever I do to one side of the equation, I'm also going to do to the other side. When writing a perfect square trinomial, remember you'll take your b value and divide it in half, and you will square that. That's what you're going to be adding in. So when I look at my y's, half of negative 6 is negative 3. Square that, and I get 9. And that's what I'm also going to add to the other side. When I look at my x's, half of 4 is 2. When I square that, it's back to 4. But when I add to the other side, please remember that that 4, please remember that that 4 is also being multiplied by this negative 16. So on the other side of the equation, I'm actually going to have to add negative 64, which is that 4 times negative 16. Okay? Then we can do a little bit of factoring. So with my x's, I have this negative 16 factored out and x plus 2 squared. With my y's, I can factor this into y minus 3 squared. And on the other side of the equation, when I add 71 plus 9, that's 80, minus 64, we've got a 16. So we've at least got these groups. We've got the x's together, the y's together. We've grouped things. But the other big thing is that it still doesn't say equals 1. So just like we did before, our next step is that we're going to divide by 16 so that it will say equals 1. We're going to divide everything by 16. And we do a little reducing. So negative 16 divided by 16, this will become negative x plus 2 squared. And I'm going to still write it over 1 because we do want to see these fractions, remember? My second one, there is no reducing, so I'll leave it like this. And now I have my equals 1. The only other thing that I don't like is that in a hyperbola, we need to see this subtraction in the middle. And we do have that subtraction. I would just say it's almost in the wrong place. So what I'm going to do next is just flip these around. Y plus 3 squared over 16 minus x plus 2 squared over 1 equals 1. And now I've got an equation that I can do a little bit of work with. Some things that you want to think about with this equation right away. Since the y comes first, we know that these branches are opening up or down. This is my a squared, this is my b squared. So my a value is 4, my b value is 1. Using the a squared and b squared, I can quickly get my c squared. 16 plus 1, which means that c is the square root of 17, and the square root of 17 is around 4.1. Okay, so we've got a lot of key information here. Now for the actual graphing. The center point is whatever I subtracted from. I just realized that I copied that wrong over here. This should have been a minus 3. We had it, and then I copied it wrong down below, which means this is a minus 3. X's look correct. So for my center point, we can see that we have an x plus 2. That means that my center point has an x value of negative 2. For the y's, I did subtract 3, so my y value will remain 3. I've got my center. And if I plot that center right away, negative 2, 3, puts me right here. Then, since my a is below the y, I'm going to go up and down 4 units. So from here, I'm going to go up 4 units and down 4 units. These are my vertex points. And right away, we can label those. They both have an x value of negative 2, but the first one is at positive 7, and the next one is at negative 1. Now, for my vertices, I'm going to go left and right 1 point. Remember, that was that b value. And then I can quickly make my rectangle connecting the vertices and co-vertices, draw my diagonals, which will become my asymptotes. And from there, I can draw the branches. Remember, these are up and down, so we're going to draw this branch. We're going to draw this branch. Okay, we've got everything here except the focal points. So the focal points, remember, our C value was approximately 4.1. So switch colors here to purple. We are going to go up 1, 2, 3, 4.1. There's my focus. And we're going to go down 4.1. There's my focus. When I'm writing my focal points, notice that they both, again, have the same x value of negative 2. When you're writing your y values, notice that you started at a y value of 3 and you went up square root 17. So 3 plus root 17. And then from that 3, you went down root 17. So 3 minus root 17. And there's my focal points. For your asymptotes, find your slope. My slope, I went up 4 units and right 1. So my slope was 4 over 1 or negative 4 over 1. So I know my slope, plus minus 4. And both asymptotes went through the center point, which was at negative 2, 3. So when I write my equation in point slope form, y minus y1 equals m times x minus x1, we're going to plug in negative 2 for the x1, so x plus 2. We're going to plug in 3 for the y1, so y minus 3. And we're going to plug in our slope, plus minus 4, and we can leave it in this form. Okay, 2 more examples. These 2, we're going to have to write the equation. You can use the graph to help you. I'm not asking you to graph it completely, but I would highly encourage you to sketch the information you have so that you can start to look at the relationship between the points, what direction is this opening, and things like that. So we want to write the equation for this hyperbola. We know that the center is at negative 1, 3. So I'll plot my center, negative 1, 3, just so I kind of have an idea of where I am. I know that I have one focus at negative 1, negative 1. So that's down here. And I have one vertex at negative 1, 4. So that's up here. Now, the fact that all 3 of these points line up vertically tells me that this hyperbola has to open up or down. And if the hyperbola opens up or down, then that tells me it has to start with y, and then I will subtract the x, and that it's equal to 1. So I kind of have the setup now. Remember that a squared always comes first and then b squared in a hyperbola. So now let's see if we can get some of these values. Now, the center we were given, so we can plug in that center right away. We're going to plug in this minus 1 with the x. Remember, when I subtract negative 1, I'll add it. Then I'm going to plug in that 3 with the y, so I will subtract 3. As for my a's and b's and c's, I was given information to find my a value. Remember, from the center to the vertex, that's my a value, so my a value is 1, which means that my a squared value is 1. Now, the other thing that we were given was the distance from the center to the focus. That's your c value, which I know is 4. I don't have the b value right now, but using the equation a squared plus b squared equals c squared, I can actually solve for that b squared. So if my a was 1, a squared is 1, c was 4, so c squared is 16. So b squared is 15, and b is the square root of 15. But technically, it's the b squared that I actually need to write my equation. So if I put that 15 in here, here's the equation of my hyperbola. Another quick example here. This one's a little different because of the information that you're given. I said find the equation for the hyperbola that has the asymptotes at this and a vertex at 3, 1. So let's think about what we know at these asymptotes. If I asked you to plot these asymptotes, remember when we wrote asymptotes before, remember that this point, 1, 1, that ordered pair that the asymptotes are crossing through, that is actually the center point. So even though we didn't come right out and say, hey, here's the center, we used that center point every time we wrote the asymptotes. So the fact that I gave you those equations, we now know that the center is 1, 1. I also told you one vertex is at 3, 1. So if I plot that, here's my vertex. Now the fact that these two line up horizontally tells us that this hyperbola must be opening left and right. Here's my center, here's my one vertex that I know. And if the hyperbola is opening left and right, then that means that x comes first, y comes second, and of course it equals 1. A squared always comes first in a hyperbola. So now we need our a and b values, and since we do know the center, we figured that out from the asymptotes, we can actually plug in that center point right away. X minus 1, y minus 1, we've got that part done. As for your a and b values, you do know that the distance from your center to your vertex is a, which means your a value is 2. So I can plug that in right away. If a is 2, then a squared is 4. Now I just need my b value. Remember your slope. your slope in the asymptote was either b over a or a over b. Every time we wrote the slope, it was one of those two, plus or minus, of course. Since we've already established that the a value is 2, then that means that this denominator must be the a value, and therefore this numerator must be the b value. And so if b is 3, then b squared is 9. And there's my equation. Okay, you don't need a lot of the graph, but sketching a few points and remembering how we wrote those asymptotes is going to be key so that you can pull the correct information out of the graph. So as you try a few of these problems, good luck. And of course, as always, let me know what kinds of questions you have.